Alright, this is Cross Products Part 3. So this is the last video of the semester. Yay! Anyways, let's finish this off. So let's take a closer look at the Theorem 10. It states that the area of a parallelogram created by an adjacent side, vector u, and vector v is equal to the magnitude of the cross product of vector u and vector v. Remember that the double vertical bars around a vertical or a vector indicate that you are finding the magnitude. So we're looking for the magnitude of the vector. Okay, which is the square root of the sum of the squares of the components. So recall from geometry that the area of a parallelogram is equal to its base times its height, where the height is in distance from the base to the top perpendicular to the base. Examining the parallelogram shown to the right, we can see that the height h creates a right triangle with a parallelogram. The relationship between h, theta, and the magnitude of vector v is sine theta equals h over vector v. So, once again, opposite over hypotenuse, right? Therefore, h is equal to the magnitude of vector v times sine theta, and thus the area of a parallelogram is area equals base times height, which equals the magnitude of u vector times the height, which is the magnitude of v times sine theta, which according to Theorem 9 is equal to the magnitude of vector u cross v. So this is the skinny of it right here, the magnitude of u cross v. Alright, so if we have to find the area of a parallelogram, you're going to have to cross the two vectors that you're given, and then you're going to have to find the magnitude of that. Okay, so let's look at example 4. All we have to do with this one is just find a vector orthogonal to both u and v vectors. So to find a vector that's orthogonal, we just need to cross u cross v. That's it. Okay? Alright, so being that said, I'm going to go ahead and use the basket weave method. So once again, I, j, k, repeat I and j. So we look at vector u, and the components for I are positive 2, for j it's negative 3, and for k it's negative 1. So I'm going to go ahead and rewrite those two. Moving on, for vector v, it's negative 4 for the I component, 1 for the j component, and negative 2 for the k component. So rewrite I and j, so I put negative 4 and 1 down here. Alright, so I'm going to work on S1. S1 tells us to work left to right, so I'm looking at I first. So I says negative 3 times negative 2, I, plus j is negative 1 times negative 4, plus k is 2 times 1. Okay, so we got 6i plus 4j plus 2k. Alright, that's sum 1. So let me go ahead and highlight that. Sum 2. I'm going to work the other way around. So I'm going to start with j. J is 2 times negative 2 plus negative 1 times 1, and that's I, plus, make that I look a little better, hold on, and then k is negative 3 times negative 4. So once again, take a moment to check your work, because I'm getting negative 4j minus I plus 12k. Okay, so I'm going to check my work, you check your work, just make sure there's no mistakes. Okay, it looks good. Now what I'm going to do is I'm going to subtract the two. So I'm going to take S1 minus S2. So we get 6i plus 4j plus 2k minus negative 4j minus I plus 12k Okay, so if I distribute the negative sign throughout this thing, I get 6i plus 4j plus 2k, and now I'm going to change signs. So negative times a negative is a positive 4j. A negative times a negative is a positive I. And a negative times a positive is a negative 12k. Okay, so when I add these up, I get 7i plus 8j minus 10k. And that is the result of the two vectors. So what is this? This is the orthogonal to both u and to vector v. Okay, so this is my answer. That's my orthogonal. Alright, example 5. Example 5 is actually going to take some time because it tells us to find the area of a parallelogram with one corner at P1 and the adjacent side vector P1, P2 and vector P1, P3, where P1 is negative 2, 0, 2, P2 is 2, 1, negative 1, and P3 is 2, negative 1, 2. Okay, this is a three-step process. So the first thing we're going to do is we got to find vector P1, P2, and we got to find vector P1, P3. Okay, second, after we find those vectors, we're going to cross them. So we're going to take the cross product of P1, P2 vector cross P1, P3. And then the third thing we're going to do, because it's asking us to find the area of the parallelogram, is we're going to take the magnitude of the result from step 2. So the cross product of P1, P2 vector crossed with P1, P3. Okay, so it's a three-step process. So I'm going to work on step number 1, finding the vectors. So I'm looking for P1, P2 first. To do that, you have to take P2 minus P1. Okay. So I'm looking at the P components and I'm just going to subtract them, so I start with P2. So I have 2 minus negative 2, and that'll give me the I component. Okay, plus, I'm looking at the J components. 1 minus 0, J, plus. Now I'm looking at the K components. Negative 1 minus 2, K. Alright, when I do that, I get 2 plus 2, that's 4i, plus j, minus 3k. Okay, so that's P1, P2. Now I have to find vector P1, P3. Okay, so got to find that. So I'm going to subtract P3 minus P1. So I'm going to do the same thing I did for the first one. I'm going to subtract, I'm going to look at P3, and I'm going to do the I components first. So I get 2 minus, now remember I'm looking at P1, negative 2, I. Plus, let's look at the J's, negative 1, minus 0, J. Plus, and now I'm looking at the K's, 2 minus 2, K. Alright, I get 2 plus 2, 4i, minus J, because it's negative 1J, and then 2 minus 2 is 0, so I get 0K. Okay, so check your work on that, make sure it looks good. And then I'm going to highlight these two. So I did step 1, I found vector P1, P2, and P1, P3. Now I have to cross these two. So this is going to be on the next page. So step 2. We're going to cross P1, P2 with P1, P3. Okay? Alright, so I'm going to set this up again. We're going to use a basket weave method, I, J, K. Okay, and once again, I'm going to repeat I and J. Okay, so if I look at P1, P2, that's what we just found before. P1, P2 is 4I, so I'm going to write the 4 down here, plus 1J, so do a 1 there, and negative 3K. So I'm going to repeat the 4 and the 1. Okay? Now, P1, P3 was 4I, so I'm going to put a 4 there, minus 1J plus 0K. So I'm going to repeat the 4 and the negative 1. Now I start the basket weave method, so I need the summation of 1. So I'm going to work on first. So I'm going to do I first. I is 1 times 0I plus J is negative 3 times 4J plus 4 times negative 1K. Alright, 1 times 0 is 0, so it's 0I minus 12J minus 4K. So that's summation 1. So we found that. Yay. Alright, let's work on S2. So once again, I'm going to start from the far right here. So I get 4 times 0, J, plus 3 times negative 1, and this is I, plus K is 1 times 4. Okay, so I get 0J plus 3I plus 4K. And that's my summation of the second one. Now we're going to take sum 1 minus sum 2. So S1 minus S2. So 0I minus 12J minus 4K minus 0J plus 3I plus 4K. Okay, so what do I get? I get 0I minus 12J minus 4K, and then negative 0J minus 3I, and then minus 4K, and I'm just distributing the negative sign. So I get negative 3I minus 12J minus 8K, and that is the cross product of the two vectors. But I'm not done. I haven't found the area quite yet because step 3, I have to take the magnitude of the cross product of P1, P2 vector crossed with P1, P3. Okay, so to take the magnitude, I'm going to take the square root of all the components squared. So the I component is negative 3, I'm going to square it, plus negative 12, I'm going to square that, plus negative 8, I'm going to square that. Okay, so under the radical, I get 9 plus 144 plus 64. Now we have to add those up, and the next step that we do is we're going to take the square root of that. Okay guys, so if I add those 3 digits together underneath the radical, I get the square root of 217, which is not a perfect square. It's close, but not quite. So this is my answer. So this is the area of the parallelogram. So once again, to find the area of the parallelogram, you have to, in this case, we had to find the two vectors first, take the cross product of the two vectors, and then take the magnitude of the two vectors, and that will give you the area. Okay, that's it. So that is all. You're done. Hooray! Good job. I'll see you in class.